Hey everybody, and welcome to Digitized Design's Scanner Spotlight. I'm Patrick. I'm one of our applications engineers. I've got the Artec Leo today, and I'm going to take you through a set of 3 mini projects that are going to show you kind of the vast capabilities of the Leo, things it's really good at doing, from reverse engineering to, inspection starting out with, to reverse engineering, and then lastly 3D asset creation. Using these scanners to speed up the process of creating 3D assets for like visualization, for like video games, movies, and things like that. You can kind of see a little bit of a preview of that down here in the corner of my screen, where we might send a drill to space here in a little bit. So starting out, just a little bit about Digitized Designs. We're a 3D scanning solutions company, so we carry a variety of hardware and software solutions that help solve problems using that technology. So Artec's one of the few hardware brands that we carry, and I'll show you a few different of our softwares as we go through today. But the Artec Leo is one of our most popular scanners. That's one we're going to be looking at here. So this is the Leo. It's a structured light 3D scanner. As you can see, it's completely wireless. It's battery powered, has everything you need to collect scan data on board the scanner here. So I've got a battery cover and a battery in there. It's good for about 2 to 3 hours of continuous scanning, and that's straight, not stopping scanning. So if you keep going, if you stop every so often, it's usually good 4 or 5 hours of scanning. It's really easy to switch batteries out. It takes about 2 minutes to do that and power down the scanner, switch the batteries out, scan it, start it back up, and keep going. You've got a really natural touchscreen interface here on the back, screen that flips out just in case you need to reach over stuff to see what you're doing. Power button that doubles as like a back button. A trigger button right here. Switch on my other camera. There we go. So maybe you can see a little closer. Like there's my touch screen. I've got the projects I've got on here. I've got some settings I could play with, and then trigger button down there. Lastly, I've got the business end of the scanner. So there's these 2 eyeballs. This one has an LED ring around it, and there's 2 cameras sized inside of here. This other eyeball is going to be your laser projector. So this one's going to project VCSEL infrared lasers. It's a VCSEL laser emitter, same type as in your iPhone's Face ID system. That laser grid is going to hit the part, bend and deform, and then this camera is going to see how those lasers bent and deformed, and interpret 3D measurements from that. So it's going to measure this huge rectangle in front of the Leo. It's capable of doing that 60 times a second. And as you move your part around or you move the Leo around, it's able to stitch those frames together using texture, so color, or geometry features on the part to do that. That's how it keeps track of where it is. It doesn't need any kind of external reference system or targets or anything like that. It's able to just use what's in the scene that you're working with. Last couple things, you've got SD card slot, you've got Ethernet on here, you've also got Wi-Fi for transferring data back and forth. Once you're done scanning, you'll send your data over to Artec Studio, and there you'll process it into your final product, your STL or your OBJ like textured mesh file. So we're going to start out with this project right here. I'm going to get my computer set up so I can show you what the scanner looks like. I can actually cast my Leo to my web browser here, so I can let you see what I've got going on. Sweet. So you'll be seeing almost everything that I'm seeing on here. I'm just going to start a new project and make sure I'm showing you what I'm seeing. Perfect. So yeah, you've got that, what you're seeing with the Leo, seeing minus a couple little like heads-up display buttons and dials and things. So once I point the Leo at something, you'll see your screen matches mine. It's showing me what the Leo can see. So this part of the part, it's also color mapping that. So it's showing me everything's green because I have the Leo a nice distance away. If I get a little too close, the distance is going to turn orange and then red, and eventually that data is not going to be seen anymore. It's too close to the Leo for it to see it. If I get too far away, it's going to go blue and then eventually fall away. Same thing there. So I want to keep this nice and in the green. It's not recording anything yet. This is just preview mode. It's waiting for me to tell it I'm ready to go. And as soon as I am, I'm going to click my trigger button. And now I'm collecting data. So now it's really kind of painting with data. I just want to make sure I cover any surface of this part I want scan data on with scan data. And the Leo is going to show me on the screen here a preview of what it's collecting. And so if I see an area that I need to fill in, I can just come back and hit that. Really quickly though, I'll fill this in and we're almost done. If I lose tracking, so I let the scanner fall off of the part since it is using features on the part to stitch together. If you point it off into space, it's going to lose track of where it is. It's really easy to recover from that. You just point it back at somewhere where you've already scanned. It'll tell you it's ready and it'll pick right back up and you can keep adding that way. Same thing's true if you stop and want to continue. Like for example, we're done. I'll go ahead and stop and I've got some controls on the screen I can use to flip this around and inspect what I've got so far. If there's something I wanted to go back and add, all I have to do is exactly what you just saw. Point back at something I've already scanned. Leo picks up and is ready to go. So it's really common you want to scan on both sides and combine those together. So we'll do that here. I'll start a new scan. We'll flip this guy over. And do the same thing. Keeping that distance in the green. It's helpful to hit a few different angles while you're doing this. You can always do one pass just on the inside here. And we can do one pass on the outside. If I'm careful, I can flip over, go upside down and get up under that lip, even though I know I've got that on my other scan. It's just sometimes really nice to do. I can get that overhang there. Cool, that's perfect. So we'll stop there, go back all the way out. I'll hook up my Ethernet cable so we're ready to transfer this stuff over to the computer. So now we're over in Artec Studio. This is our scan data like analysis and processing software. So I'm going to import from my Leo. There we go. So that latest project, I've got a list of all the projects that I have on board here, but that's the one I just did. So we're going to import that. What it's doing when it imports is it's transferring all the data over from the SSD. You've got 500 gigs of storage on the Leo, half a terabyte. I don't think I mentioned that earlier. But it's going to transfer that data over. It's going to unpack it, and in this case, in most cases, it's going to run an HD reconstruction. This is a really cool extra feature that got added a few years ago into Artec Studio. Enables a little bit higher resolution and better scanning in really typically difficult scanning situations where you've got really shiny parts, really fine features, or things like that. So once that data is finished transferring, it's going to pop over into Artec Studio in pretty organized. It's got two projects. This is the first one, that part flipped over the other way, and then the second one with the part like this. This one is 3 separate little scans because I stopped and started it 2 times. I lost tracking once and regained it, and then I paused on purpose one time and regained tracking, but we can treat all those as one. I'm going to turn off my color here. It makes it a little easier to see what we're looking at. So a couple neat things I need to do. I need to delete the background out of these, and then I need to combine them together. So we're going to grab an eraser tool and really quickly delete out the background. So I painted the floor. Artec will fit a plane to that, and then delete that floor out. And I can scoot that plane up and down because usually at first it's not quite where you want it. You want to scoot it up a little bit, but it's really easy to scoot that up. Make sure you're completely clearing out the floor. I might be nipping a little bit of the part out, but that's totally okay. I know I got that part here on the bottom on this other scan. So now I have 2 scans cleaned up, but they're not aligned. So I've got tools that help me do that too. I can spin this one around. Notice it colored one blue and one gray. The blue one's just one that's going to stay put. The gray one is the other one that's going to move around. I can move that gray one around manually, or I can do this point pairs picking. Usually you want to do a little bit of both. Move the gray until you're looking about the same side of each one. Pick common pairs on both. And as soon as you have 3 pairs, you can snap those together, and then the computer will take over and finalize that alignment. Computers are really good at finishing the last little bit of an alignment, but they really speeds them up if you can give them a good alignment to start with. That's what those 3 points really help us with. Once we've done that, we've just got two last processes we want to run through with this. One of them is registration. So we aligned between two groups, or two scans. This is going to align between the individual frames in these scans. So I mentioned as it's scanning up to 60 FPS, it actually, when you do an HD reconstruction, you get a smaller number of higher quality frames. But in this one, for example, I've got 80. Each one of those is a separate image that this took, that the Leo took, and this alignment is going to happen between all of those simultaneously. You can kind of see the before and after of that's not registered, and then this is registered. You can tell that's aligned a little better. Very last thing we're going to do is run a fusion, and perfect. So this is going to turn all these individual frames into one mesh that we'll be able to use for whatever our downstream process is. In this case, it's going to be inspection. I'm going to bring this over into Polyworks, a really awesome inspection tool to compare to a CAD model that I have ready to go and make some measurements on this. So there's my fusion. One last thing I wanted to point out here. We are, before we meshed and after, technically they're both triangular meshes, but after we mesh, we're one single triangular mesh. Polyworks calls it a polygonal model. But if we zoom in really close here, you can see all these triangles. I picked a resolution of 1 millimeter for my fusion. You can go smaller than that, all the way down to 0.2 millimeters. Basically what that number is how small those triangle edges can get. So in this case, 1 millimeter. My edges could get sharper if I do a higher resolution, but this is plenty of resolution for this part here. But something I want to point out, all these triangles are about the same size. They're all kind of minimum size. Something else we can do is run a mesh optimization. That is going to reduce the number of triangles, but it's going to do it in a really intelligent way. It's only going to take triangles where it knows it can do so and not lose any information. So I just ran that. Those triangles got bigger in certain areas. We'll do it again just to see those triangles get even bigger. You can see the bigger triangles show up in flatter areas or areas of lesser curvature first. So it's going to throw away as many triangles as it can, but only while keeping the maximum amount of information. Last thing we'll do, we'll go ahead and export this to a folder on my desktop. And cool. So we'll do that. We'll bring it over into Polyworks. So I've got a CAD file here ready to go. I'm going to tell Polyworks I want to bring in my new polygonal model, that one we just made. It is in millimeters. So it's going to pop in here. It's not going to be aligned just yet. The Leo does a really good job of it. Tries to align it based on gravity. So you can tell the Z-axis is always pointing in the right direction. Polyworks is going to grab this. It's going to do an automatic alignment on it and snap it to the CAD model. So automatic alignment doesn't always work. If it doesn't, you have a fallback in point pairs, but automatic works a lot of the time, especially unless something's really symmetrical. Sometimes it can get swapped, but automatic alignment, that's the first step you've got to do. And then if you want to grab a couple of features to do a more repeatable alignment, you can grab a plane and a few holes, for example. And then we can grab all of those features, extract them, and best fit to them. So now we're doing alignment based on those features. Notice the data shifted a little bit. So if there's my best fit, there's my fit to those objects. Now if we want to make some measurements, for example, we could grab some distances here. Let's do hole to hole. We wanted an angle. We can go grab a plane from somewhere else. It's not that top plane. And then do an angle from, let's say, this plane to this plane. And pause to decide where we want to throw that. So it's a small angle there, about 1/2 degree, but we can measure it. And then as soon as we've got something that looks like what we'd want to throw onto a report, we can do that too, arrange these how we want them, grab that dimension. This is what I want to put on my report. Hide those features. Something else you'll commonly want to do is check a couple of points and just see how close they are. Let's say point right there, point right here, point right here. Notice those are all color coded. So that purple one's going to be my lowest of those three. The green one's very near the middle, and this red one's near the top. This is a really quick way of just checking how close your your new part is to the CAD model there. Very last thing you might want to do here is a heat map. So this is just going to color code the whole surface of the part since we got scan data on all of that and show us how well it fits. Right now it's showing that it's all green because my map is up to 8 millimeters up and 8 millimeters down. So let's drag that around until we start to see some of those extreme colors on both sides. And you'll start to see now some information. All those blue areas means I've got less material. Anywhere I've got the hotter colors, the orange and yellow and red, I have excess material on my part. So yeah, there's your example of how you can use the Leo to measure some stuff. Once you've done, set your measurements up, all those are dropped into a report for you automatically. Everything that we've set up here, anything you've by default that's reported on those features, got a whole table of all that information. It's really easy to customize this. If there's a column you don't want, you can throw that out. If there's something about one of these circles you want to add to it, there's a whole list of things that Polyworks can tell you about those circles or those features that you've extracted. Lastly, this report's really easy to customize. Say I want to slide this guy around and just drop this screenshot that we took at the end into the beginning here. We can do that, drop it right on top of this, make that a cover page, delete this page here, and this report's ready to go. Something else really powerful about this, if I've got more and more parts I want to do, I want to run this again, all I've got to do is hit this new piece button, and we're going to use the same scan, but I'm going to pretend that we scan this again, and drop a new scan in here, and it's going to repeat all these steps automatically. I don't know if you heard that ding. That's the ding it does when it's done measuring. So now I've got two pieces. As quickly as I scanned that again, process it in Artec Studio, drop that scan in here, now you've got a second piece. You can even do that again. Turn my volume down a little bit. Do one more, it's asking me where my new scan data is. Boom. So right there we've got 3 different parts, and we can throw in, we can check some statistics. Polyworks does SPC, statistical process control. So say for that distance of that angle that I extracted, I want to see how those work out on all 3 of these parts that I made. I've got all those statistics here we can look at, as well as a whole other range of statistical figures that you can ask Polyworks to compute for you. Cool. All that said, I'm going to move on to my next project here. So we're going to clear out Artec Studio, and I'm going to switch parts out. So that was our inspection project. Next for you, I have a reverse engineering project. We get a lot of customers that work with like automotive parts, like our aftermarket automotive stuff. They've got cars that they need to scan to make custom stuff for. And this is kind of a simulation of, we see a lot of exhaust brackets. Leo's really quick at picking large amounts of scan data up. We've got customers that use it for scanning the underside of cars, inside of engine bays, things like that for exhaust systems. Sometimes they need to know like these planes and then bolt locations so they can know where to put a bracket to pick up on the end here, where to put a holder to throw on one of these like exhaust tube lengths here, and then where the tube is so it doesn't run into anything else on the bottom of the car. They can scan the bottom of the car, scan the exhaust off to the side, and virtually put those together so everything's right. They don't need to remake any brackets or anything. Everything just bolts together the first time. So I'm going to scan this tubing on my tabletop here. We won't do 2 scans on this one. We'll just do the one and combine it together. Or sorry, we'll do the one and just use that to do some simple reverse engineering tasks regarding this tube. So we're ready to start scanning, and I will do so. Notice this like black surface here is a little bit tougher to pick up, which that just means you have to get a little bit more perpendicular to it. Like when I swing around the other side here, it doesn't like to pick up at first, but as soon as I swing around fully, it picks up. There's some things that are impossible to scan. Things that are completely transparent or very, very shiny do give the Leo trouble, and those always you can tackle with spray or something similar. But a lot of commonly difficult to scan surfaces, HD mode really does a good job of picking up. So I'm scanning here. Notice I'm using the table surface as extra information. If I had this pipe just floating in the air, that would probably not be enough information to use to keep tracking, since it's just that one pipe and it's filling so little of the field of view of the Leo. But you can always use background information. Even though I'm not going to keep the table in there at the end, I will be able to use all that info to help me register all this together really quickly. So I'm just going to get the other side here real quick. Awesome. So we'll back out of here, plug my Ethernet cable back up, get this transferred over. That last project and bring that data in. Let me go ahead and switch my parts out while that's going to my last project of the day. Hopefully that doesn't fall and make a super loud noise. That'd be unfortunate. Cool. Got our scan here. Turn off that texture. There we go. So this one I don't have to do as much cleanup. I could just go ahead and run registration in Fusion like this, but I'll just do a quick isolation of some of these surfaces that I want. Actually, we'll keep the table for right now. Get rid of some of that noise, get rid of some of this down here. Run this through a registration. And then we'll take out a little more information. It's really helpful to have all that extra stuff in there for the registration. It's not as necessary for the Fusion, so we'll delete a little more out for that. And then run that Fusion. Let's do a sharp Fusion at 1 millimeter. Perfect. I'll crunch for just a moment. I'll set up my last project. We're going to be bringing this one into Geomagic Design X. So this is reverse engineering software. We're going to extract some CAD features from this. What Design X usually does is allow you to create full CAD models, all the way up to anywhere from a few CAD features up to full CAD models, but we'll get to that. We'll run through Artec Studio again real quick. So I've got my mesh ready to go. I'm going to do a little more cleanup now that we've got the mesh made. This time with my lasso tool. Get rid of the plate right there. We'll get rid of that tabletop. Perfect. A little bit more right there. Boom. We'll export this as a mesh. This time we'll do an STL. Call this thing exhaust. Go over to Design X. So again, the Design X intro. Design X is a fully fledged CAD modeler. So it's capable of making the same like solid models and surface models as something like SolidWorks or Creo or CATIA or any of the big CAD modelers. On top of those modeling tools, you have a whole suite of tools used for using scans like this as really accurate 3D templates for making those CAD models, whether that's pulling geometry, planes or axes, pulling cross sections and fitting sketches like lines and arcs and circles to those cross sections, or even creating whole features, cylinders or primitives all at once. And then also checking how well your model fits your scan, because you really want to do that as you're going. So we'll import the scan we just did from our Artec export of that tubing. And we'll do a few things here. Usually selections are really difficult to make on mesh data. And so something that Geomagic does that's really cool is it allows this smart selection. So usually you're limited to like a paintbrush or like a lasso, which those will work, but they can be difficult and clunky for like mechanical surfaces. Like if I want to grab this tubing, I've got to kind of spin this around and hit it from a few different angles. But I've also got Smart Select, lets me click in one spot and hold and drag up and down and really select basically mechanical faces really easily. It'll select up until a certain angle threshold, and then you're controlling that angle threshold with the up and down. So if I click and drag around, usually I can get a plane or a cylinder face selection really quickly. So say, let's grab a plane off of this end here. We'll create a new plane. And so we want to make that this planar face. We'll do a mesh sketch, a regular sketch, but with a preparatory step of letting you slice through the mesh with a plane and then use that mesh cross-section to as a template, again, for creating this CAD feature. So I can tell this is just going to be a few different lines. Depending on how clean my scan is or how clean the part is, it's going to break this up and tell me what it thinks are different lines and arcs. So I know I've got a couple circles here, I've got a few lines here. I can grab my line tool, and instead of having to eyeball where that line goes, I can just single click and get a line to go right there. Same thing with right here. I can go around and build this up like that. And I can even ask DesignX to do more on its own. If I wanted to just auto sketch some stuff, I can just then box select and have it automatically fit sketch primitives to everything. In this case, I'm going to do the rest myself because it's almost done. And then come back through. Oops. I want to trim those together, not cut them. There we go. Trim, trim, trim. Make sure all the ends are together. Last thing, throw a couple of circles in here. If you know there's part of this that you don't want included, you can always exclude it. But really quickly, we've already got the profile of this plate. Oh, I left that last circle out. Circle. Perfect. So we've got that sketch profile right there on that face. So now we can just extrude it on top of the mesh. It's also where a cool benefit of working with your CAD right on top of your scan comes in, is I can just eyeball it. If I don't know how thick this is, I can just turn to the side, grab this arrow, and eyeball how thick that is. 6 millimeters looks pretty good. But I can even check closer, hit this accuracy analyzer button, and I can see it looks like I'm about 3/4 of a millimeter short. So it's probably more like 1/4 inch sheet, but we can go ahead and punch that 3/4 in there and see some of this turn green. So this accuracy analyzer is color coding everything that I'm making based on this color scale over here. So anything that's green, it's showing me within 1/10 of a millimeter, which is probably pretty tight for something welded. Let's drag that out to about 1/2 millimeter. And so now everything is within 1/2 millimeter, shows me green. I know I'm happy with that, and I can accept it. So I've modeled that plate, and now I've got those cylinders in there. If I want to use those as references for how to align this, or into like SolidWorks, is to mate this up to another assembly, or to know where a bracket needs to reach to be able to pick this up and bolt something to it. If I want to keep going, I can do a pipe wizard. If I want to just model this pipe, I can. I have automation tools that build on everything I've shown you so far. They'll combine different aspects of them together and give you even more on top of what they're already doing. So let's say I want to do a pipe wizard. So all the wizards will basically take those sketch components, like you give it a part of the mesh that you know is made a certain way, like as an extruder or a valve, or in this case, a sweep of a circle. That's what a pipe, what makes a pipe. And it'll go figure out all the components that it needs to model it. So the pipe wizard is gonna take this geometry that I've given it. I'm telling it, I think you can make that with a circle and a 3D polyline to like mimic the way this pipe was bent. And just tell it that's what I want it to do. And it's able to recreate that. It's able to do those lines and arcs, these straight line tube sections with fixed radius bends in here, and model all of that for me. If you ever had to model something like that in like SolidWorks, for example, you know how big of a deal that is, that it can do that really that quickly. You can go back and edit these things, but now I've got that even modeled in there as well. So I could continue, I could make that flange on the other side, pick up those couple of cylinders, and then we've got the whole exhaust modeled to be able to put this together, whether it's just to have all this information to make other things made up to it correctly, or if you wanted to recreate this for some reason. Now you have all the measurements in here. You have a CAD model of this part, which is, in most cases, the first thing that you want to start with to create a new one. Cool. Moving on to our last project of the day. see. Just switch back to our couple of camera views for this one. You've kind of seen what the scanner looks like. So this is just a power drill, and we're going to capture this with the Leo, and this time we're going to process it in full texture color. So that's something we could have done this whole time. We've left the color information always gets captured. We just didn't apply it to our model for that last step for each of these projects we've been working with so far. But for this one, we will do that particularly. And I'll show you what that looks like. So the scanning process is exactly the same. For something this small, it's even easier. You kind of keep the Leo just pointed to the center here, hit a few different angles, rotate this turntable around. Cool. There's that. I'm going to hook up my Ethernet cable one more time. So we scanned. I've got my Leo hooked back up with Ethernet, and we're going to bring in that scan data again. So I've got this drill scan. We'll bring into Artec Studio. And this one's very similar to the first time, or the last project we did, the pipe, where we don't need to combine two different scans together. We just have this one position that we just want to kind of clean up some excess from. We'll get out anything we don't want out of there. Then run this through registration, and then a fusion. So this is fusion. We'll still come back and delete a little bit extra out of here. Run that through a very simple simplification process where it's going to take out some all that noise and a little bit of simplify the mesh down in triangle count. And something we didn't do before, we can apply the color texture that was captured by the Leo to the final product. So select those pieces, the thing I want to apply texture to, and the things I want to use to apply that texture. Do that process, and here we have a fully color 3D model of this little power drill. Kind of zoom in and look at some of those texture details it's able to capture on like the label. We can save this off as, we do have to do an OBJ. STLs do not store that color texture information by default. Something I always really like to look at is the way it stores that information. It has to do it does a 3D model, so you've got your OBJ file that stores all the 3D information. You've also got an image that's just, it takes that scan and it unwraps it, and it stores all the color information in this. So you can kind of see the strategy it used to unwrap this. You can see all the little pieces of the model there, and it's able to use that information to the 3D model and this image in the third file that it saved off to basically wrap that image back around the model to color it up the way that it needs to be. And then you can do something like drop it into something like this is Blender, a 3D art, 3D graphics program, and right out of Artec Studio, it's ready to drop into a 3D scene like this. This is a scene of like the Earth in space, as you can see, and it's ready to work with all the lighting and any kind of environment here to make realistic 3D renderings, or it's ready to drop into like a game engine to be in a video game as an asset there. So really powerful tool you can use. Sometimes those, like I said, sometimes the 3D assets are ready to go out of Artec Studio. Sometimes they're a really awesome jumping off point, like for a 3D artist, where they might take 8 hours to make a full asset from scratch for something like this based on photo references. Maybe they can do that in a fraction of the time with starting with a scan from the Leo. They clean that up instead of create a whole one from scratch. So for anything like your virtual try-ons for glasses or for shoes or for furniture in your house. Somebody has to make a 3D model for those to work, and this is a really cool way to get there quicker and more efficiently. So this has been the Leo Scanner Spotlight series. Again, I'm Patrick. This is Digitized Designs. If you have any interest, something here caught your eye, you've got some questions or anything, we would love to talk to you. Please feel free to reach out. We've got our website, digitizeddesigns.com. You got phone numbers and emails you can reach us from. Comment on this YouTube video once we've got the recording there. And yeah, thanks for watching, and we'll see you next time.